Okay, so we've been dealing with polynomials in this unit. We've been solving things that usually don't factor and then finding the zeros by P over Q. So right here, now we're continuing with polynomials, but in a different way. It says, polynomial functions can be degree 0, a constant. They can be degree 1, which would be linear, degree 2, which would be quadratic, degree 3, cubic, and then so on. So polynomials will have some degree. You can use polynomial functions to model many real-world situations. The behavior of the graph of a polynomial function of different degrees can suggest what polynomial will best fit a particular data set. You can use a graphing calculator to help you find functions that model the data in the table shown here. So for example, we can have a bunch of data points, a set of xy points, and we can decide if it's linear or quadratic or cubic or quartic, all based on the line of best fit. So let's pretend that I graph those points. I'm not going to have you actually graph them. So just pretend right here, here are the points. I've graphed the points in that XY chart. So do you see how if I draw a line, they definitely don't connect? They don't connect with the line. So it's not linear. Quadratic is getting better than linear, but still not a perfect fit, is it? Could cross them perfectly. But boom, look at that. A cubic is fitting them perfectly. So these xy points are a cubic polynomials xy points. Alright, so here is one rule that you will want to write down on the top of your little worksheet here. It's called the n+1 point principle. So what this says is, for any set of n+1 points, in a coordinate plane, that pass the vertical line test, so we just have to make sure that they actually are a function, there will be a unique polynomial of degree at most n that fits the points. So our degree would be at most n. So everybody, if there's n+1 points, the degree that will fit that is n. Did everybody hear that? n+1 points, the degree that will fit it will be n. So let's say, everybody, look, let's say I gave you 3 points. Well, actually, let's say 1, 2, 3. Let's say I give you 4 points. What degree would it be? 5. 4. If there's 4 points, what degree would it be? 4. 3 people. 3. Look. Its degree n isn't n+1, 1 larger than the degree. So let's look here. If there are 4 points, there must be degree 3 that fits these points. Do you guys see? Oh, it's 1 less than? Everyone? Okay. Alright. Okay, so I'm going to test you again. If there were 5 points, what degree would it be? 4. If there were 3 points, it'd be? 2. And then 2 points would be? 1. Now that makes sense. Look, 2 points. Won't there be a line that fits those 2 points always? Yes. Okay, awesome. Now guess what? It says right here, what polynomial function has a graph that passes through the 4 points? Now I do need to point something out here. Don't quadratics have more than 3 points? Yes. So if we have 3 points, we go with quadratic. Well, there could be a quadratic with, quadratics have a really infinite number of points. So let's just read this last little thing here. It says, this principle confirms that any 2 points determine a unique line. Now 3 points that are not on a line, so if there's 3 points, there could be 3 points on a line, correct? But it says if there are 3 points that are not on a line, then it will be a parabola. If there are 4 points that are not on a line, or a parabola, then it would be a cubic. Does that make sense, everyone? Okay. Alright, so everyone, it says right here, sorry. What polynomial function has a graph that passes through the 4 points? So we're going to use the n+1 point principle. We're going to have some polynomial of degree 3. Now we're just going to actually use our calculator to find it. We could do this the long, hard way. We would be able to go like this. Y is equal to ax cubed plus bx squared plus cx plus d. And then it's going to be a whole heck of a nightmare, I'm telling you that, to do this by hand. The cool thing is we're going to just use our calculator. Here's why. This is real-world problems. And if you go into engineering or if you become a statistician in the real world, you're going to be using a calculator. You're going to want to be accurate, so you're going to be using calculators, so we'll use one. Here we go. Everybody pull up your calculator with me. Follow me through this or else it gets confusing because everybody's going, what? What? Mine's not doing that. Okay. So everybody, we're going to reset our calculator so that nothing weird's going on. So everybody hit second plus sign and then reset it. Hit enter. Reset, all RAM, yes, and reset. We do want a fresh, brand new calculator. Okay, now what we're going to do is is everybody with me? Go to the stat key. Stat key. Then go into edit. Hit enter. Now in list 1, what you type in is all of your x values. So back to this one. Our x values, 0, 1, 2, and -1. You don't even need to put it in order. So hit 0, enter. 1, enter. 2, enter. -1. Make sure you don't type in -1 or it's going to say error. Now go over to list 2. You've got to type in the y values that correspond to those x values. So in that same order. -3, -1, 5, -7. Okay, now here's what will give you errors. If you have an extra thing typed in, like let's say I accidentally have an 8 but no x, it's going to say error. So you have to have things match up. Now we decided it was degree 3, so everybody hit stat again. Then go over to calculate. Now look what it has right here. Starting with number 4, it says linear regression line. We decided it wasn't a line, so we're not going to do linear regression line. Right here it says quadratic regression line. It's not a quadratic. Regression line just means polynomial. Then cubic regression line. We said it was cubic, didn't we? So hit enter. Then it should show you something like this. If you have a way advanced calculator, it's going to have more to it. Just enter through till you see the same screen that I'm looking at. Now look, it even gives you, cubics have this form. This is what A is, this is what B is, this is what C, this is what D is. So my answer would be, give me what, so it would be y is equal to negative, wait, what was A? So x cubed, then what?
Minus x squared plus 2x minus 3.
Sweet, there's the cubic that fits those points. So if you plug in any of those x's right here, you should get out what the y value is. It really does work. So now look how nice this is. What could I now use this for? Let's say I said, okay, for these xy points, find the cubic polynomial, and then tell me what the function is at x equals 10. What would you do? Plug in 10, and then I would know what our function is at 10. Everybody sees, you know how functions work. Okay, cool. Now here is one thing I'm going to have you actually turn on. We need to turn on what's called our diagnostics on our calculator. So there's going to be this little thing right here that gives us a percent of how good of a fit our polynomial is for those points, which is going to be important in the future. But we have to turn our diagnostics on. So everybody hit with me. Second catalog in the 0. So second 0, everyone. Second 0. Then scroll down to the words, you have to go down to the D's. Diagnostics on. So scroll down to D's, diagnostics on. Okay, diagnostics. Almost there. There it is. So I hit enter, diagnostics on. And then I'm going to hit enter to like turn it on. It says done. Okay, so now actually, we probably should have done that first, but that's okay. So now watch, just watch. Let's say I went stat over to calculate. We knew it wasn't linear, but let's pretend we wanted to see if it was linear. I can hit linear, hit enter. It'll still give you an answer. It's for those points, a linear line would be 3.8x minus 3. Now this r squared is telling you how good of a fit that line is for those set of points. Now look, it's 0.96. So r squared is the percent of good. So this is a 96% accurate fit. 96%. That sounds pretty accurate, but it's actually not super accurate. Like we want it to be in the 99s, everybody. So it's a 96% fit, not terrible, but not that great. Yes. It's a perfect fit because it's 100%. So then let's say you forgot the n plus 1 point principle on the test. You just go through stat and you would test them all. So then I try quadratic, hit enter, enter. Now look, r squared is 0.97. That was better than linear. 97%. Then stat over to calculate. Let's try cubic. And then look at that. Like she said, R squared is 1. That's 100% perfect fit. So we go with the cubic. Awesome. Cool stuff, right? You should act more enthused. Now look how cool this is, because on the ACT, there are tons of stuff that say, find the lines that crosses through these points. It would take you a longer time to do it by hand. You could say, okay, I can find the slope, and then I'd have to do y equals mx plus b and plug stuff in. Instead, you should be using this calculator to go quicker and more efficiently. You'd say, oh, I can find a line by typing this into in list 1. So everybody hit stat, edit. You guys do it. I'm not going to pull it up again. So I am going to show you one actually cool thing. So in list 1, you'll type in 4 and -3. In list 2, we'll type in -1 and 13. I want to show you something. You can clear out your list like this. Stat, edit. Do not go up here and hit delete. If you go up to list 2 and hit delete, your list 2 is going to go away, and I don't know how to bring it back. You need to restart your calculator. What you can do is go up to list 2 and hit clear, and then once you scroll down, it clears out the list. So look, I'm going to scroll up, highlight on list 1, I hit clear, and then when I scroll down, it will clear it out for me. So you guys have number 1 on your paper if you'll look at it. Wasn't it number 1? 4, enter. What was the other x value? And then the y values? -1, enter. 13, enter. We'd say, okay, it's 2 points, so we're going to go with linear. If we didn't know, we would just test things. So over to calculate and linear regression lines. This is a line. Something's saying error, so I'm going to hit go to. Okay? I put in quadratic regression line. It wasn't quadratic, was it? We don't even have enough points to make quadratic. That's why it said that. We only have 2 points. I accidentally hit quadratic. We need to be doing linear. And r squared's 1. So we now have y is equal to -2x. 2x plus 7, right? Sweet. Okay, awesome. Good stuff. I think we get the picture here. Do you? How many? Okay, cool. I think we get it too. 1 through 8 go. 1 through 8 go. We'll often hire a statistician to come in and they'll say, here are the books. We've kept record of everything, but we don't know what we can expect in future years. Like how much production are we going to make in year 2020 if we continue with this trend? Well, it's actually, you're going to be making the big bucks to do. Type it into your calculator. The big bucks. Like we looked it up, and statisticians make median, so in the middle, 80,000 up to 130,000. So if they make a lot of money, maybe one of you will decide to go into stats. Okay, so for example, this company produces gold. Now they have kept obviously records. So starting in year 1985, they made 49.3 millions of troy ounces. Troy ounces is how they measure gold. So 49.3 millions of troy ounces. In 1990, they had a production of 70.2. In 1995, 71.8. In 2000, 82.6 millions of troy ounces. Now, they might hire you and they'll say, what can we expect to make in year 2010? So you're going to want the line that represents the data points. So what we're going to do is, well, it says right here, let x be the number of years after 1985. That's important to read. Let x be the number of years after 1985. How many years is 1985? How many years after 1985 is 1985? 0. How many years is 1990 after 1985? 5. 10. 15. Does everybody see how this works? You do need to read that. Okay, so everybody go to stat edit. In list 1, type in your x values. 0, 5, 10, 15. And in list 2, type in your y's. Now, with story problems, we're always just going to want to use our diagnostics, honestly, because a company is going to have years and years and years and years worth of data. You're not going to use the n+1 point principle in real life. And we're letting you just use your calculator because this is a real-world problem assignment, and in the real world, you'd be able to use a calculator. You'd be urged to use a calculator to be accurate. So, try linear regression line, see what r squared is. Try quadratic, see what r squared is. Try cubic, see what r squared is. Which one is like a perfect fit or the best fit? Cubic. Now look, there's a ton of decimals here. Now think about it. In the real world, there's not going to be perfect numbers. It's going to be decimals in real life. So that's okay. Now, the more decimals you write down, the more accurate your final answer is going to be. So let's just all agree to go to like 3 or 4 decimal places, roughly. 3 or 4 decimal places. So number 1, you said that r squared was 1 when it was degree 3, so that means it's a perfect fit. So we'd say y is equal to 0.038x cubed, true? And then minus 0.956x squared plus 8.01 x, and then plus 49.3. Now what we can do is we can take this line, or not line, but cubic, this polynomial, and we can find future expectations if things continue in the same trend, and we can even go back in time. So let's see what year 2010 is. Now look, this is answering number 15. It says, on number 15 it says, what can you estimate the world gold production will be in year 2010? So now couldn't we just plug in, that's a 0. Can't we just plug in something for x? And then when we get out, y? So what would we plug in if x is 2010? 0, 5, 10, 15, looks like that's going to be 25. So plug in x is 25. So here we go. You would go back to your home screen, like the completely home screen, and you type in 0.038, then 25 cubed, minus 0.956 times 25 squared, plus 8.01 times 25, plus 49.3. So you can tell this company, you just got hired the big bucks to tell this company in the future what they can expect. How many millions of troy ounces? 245.8 roughly troy ounces. Millions of troy ounces. That's what they can expect in year 2010. Now let's pretend that they actually opened, let's go back here. Let's pretend they actually opened in year 1975. But they had a fire in year 1985 and all their records burned to pieces. Well, they started taking new records starting here, but they said to you, we kind of want to know what we produced on our first year of opening. So can you go back in time and determine what we probably made? So what would we type in for x here? Negative 10, right? So we type in negative 10, and then we could say, if things are continuing in the same trend, you probably made about this much on the first year. So cool stuff. Does that make sense, everyone? You'd be hired the big bucks just to do that. Okay, I think we get the picture here. Now I'm just going to read this, and I'm going to let you just go for it. Pretty much the rest of the time it says, find a cubic and quartic model for each set of values. So we're going to do quartic and cubic, so write down both. And then it says, and then determine which model best represents the values. Won't you just look to see which r squared is better?
Yeah.
Yes. Yes.
So you think, are you only determining out of cubic and quartic, or
Yes.
something else?
Yeah, just based on the instructions, yes. Just cubic and quartic. But on all the other ones, let's try all of them. Because we just for future practice. Okay, awesome. Now look at number 15. We just did 15 and 9, but I'm just going to give you some to take off. It starts to become busy work after once you've done one, you know how to do that and that, right?
Yeah.
So what I want you to do is on 15, 16, 17, and 18, only do the first year they ask. So on 16, you'll only do year 1986, because after that it's just busy work. In 17, it's 2002. And then in year 18, it's 1970. Only do that. And then, yeah. So the rest of the time pretty much is yours. Ready, go. Okay. Guys, remember if your calculator gives you a decimal, like let's say that it gives you, like right here, it gave us decimals back a second ago. You're going to get decimals. Watch out for e's. Like let's say you would have got this. 1.333, your calculator, and then it goes e to the negative 3.
Oh, that's scientific notation.
Yep, scientific notation. So you'd actually have to go, well, that is actually 1.3, move it back 1, 2, 3. Wait, 1, 2, 3.0013. Does that make sense, everyone? So go like 4 decimal places on these. 3 to 4. Make sure you don't just use 0 though. So go enough that you don't just use 0 if it's not 0. Honestly, the more decimals you use, the more accurate your answer. There's no. Good question. You can't use e in your writing. That's not what it is. It's just your calculator doesn't know how to write it.